Welcome! We are mastering RAG, Retrieval-Augmented Generation, and vector databases. This video will demystify the core concepts, tokens, embeddings, and how they function as AI memory. First, let's explore the AI's blind spots. ChatGPT suffers from amnesia due to a fixed knowledge cutoff, and ignorance because it lacks access to your private internal data. Worst of all, it can hallucinate, confidently generating factually wrong answers. AI doesn't read words, it uses tokens. One token is roughly 3/4 of an English word. Costs are calculated per token, and the context window represents the AI's limited short-term memory. Embeddings convert tokens into a high-dimensional vector, a list of numbers, to capture semantic meaning. Context matters, so words like apple will have different vectors depending on the surrounding text. This proximity equals similarity in meaning. Since meaning is represented by coordinates, we can perform math on concepts. The famous example is king minus man plus woman equals queen. This geometric intuition underlies all modern embedding models. The art of chunking solves the problem of diluting meaning. We slice large documents into smaller chunks, giving each a specific, searchable vector, making the content highly accurate and detailed. Traditional databases search for exact keyword matches. Vector databases search for meaning, finding pup when you search for dog. They use approximate nearest neighbor algorithms to search billions of chunks in milliseconds. RAG, Retrieval-Augmented Generation, gives the AI an open book exam. LLMs hallucinate because they have fixed memory, but RAG retrieves facts from your data first and then generates a grounded answer. The RAG pipeline has 3 steps. First, index your private data into a vector DB. Second, retrieve the top relevant chunks for a user's question. Third, generate the answer using only that context. In customer support, RAG transforms rigid scripts into intelligent conversations. Instead of decision trees, the system loads the entire knowledge base. The bot retrieves the exact policy and writes a custom, accurate response instantly. For legal and compliance, RAG turns hours of search into seconds. A lawyer asks a specific question. RAG searches thousands of pages simultaneously, extracts relevant clauses, and summarizes the risk immediately. Let's see the code for indexing. We initialize OpenAI and ChromaDB. Then we take a text chunk, convert it to an embedding vector, and add it to our collection in the vector database. For the RAG query, we embed the user's question, retrieve the closest matching document chunk from the vector DB, and feed that context, along with the question, to GPT-4 to generate the final grounded answer. You now understand RAG. The key takeaways are: build by chunking docs, store embeddings for instant search, and generate answers using the LLM with your real context. Memory is no longer an AI bottleneck.